Hi everyone, welcome back to Java on For All. Continuing the concurrency saga, let's talk a little bit more about the future. We saw that with the executor service and with whip as a callable, we get this future back. But why and when would be this useful? So when we are working, we are developing software, we have to be aware of two ways of processing data, synchronously and asynchronously. Synchronously means that it happens at the same time. So for example, all the programs that we have been doing so far up to the threads, they are synchronous programs. We have only one thread that's going to execute everything top down. So for example, imagine that your system is going to retrieve the dollar quotation from a specific server, a remote server, a bank, or a TransferWise, for example, and you have only one thread. So your main thread is the one responsible for handling your UI, and then the same thread is responsible for going all the way to the remote server, get the data, and send back to you and display in the screen. So what happens if you have only one thread is that the one responsible for handling the screen is now busy doing the request. So it means that the screen will be unresponsive. You can't do anything because the thread, the worker responsible for do the things in your screen are busy going to a remote server. And what happens, for example, if that remote server takes like 20 seconds to respond? You have to wait 20 seconds to get your screen responsive again. So in this type of cases, you would like to do things asynchronously, and to do things asynchronously, you have to assign a new worker. In this case, the new worker that we are assigned is a thread from the thread pool. So basically, you have the main thread being executed like normally as always. And then when we want to do something else, in this case, when we are trying to get a random number, a new thread is assigned. So the main thread is free to continue her work. So let's see this example. Let's just simulate this example. Let's create here inside test a future test 01. Let's create executor. Executors. Let's use just one thread because we have the main and we will have this one. This one will be responsible for go all the way, kind of technically. Let's just simulate that to retrieve like the dollar price of the day. So we are going to request actually get the response as a future because we don't know when that will be available. That's why we have this future. And we can call dollar request. And this will be a callable. So we can create here callable. We were creating a whole class in the previous video, but here let's just use anonymous classes. So you can create a callable like this and let IntelliJ handle the changes to functional programming after you provide it, because yeah, it's you can replace with lambdas now, but then you have to provide all the curly braces and everything. So it's just better to write here and then later on you change it. So what I want to do, this callable, this call is responsible for going all the way to a remote server. Let's say that it will take 2 seconds, time unit seconds, sleep 2, and then we're going to return, for example, 5.35. This is the price of the dollar of the day based on any currency that you might like. Okay, so now we can make this a little bit more functional, replace with lambda. And now we will do the following. So while you have this thread from the thread executor going all the way to this server, kind of server, we are going to do something else. Just imagine that the main thread is busy doing something else. So let's create here private static long do something. Very creative, but just bear with me for a moment. Let's get the name, and then let's imagine that we are just doing some sum. Let's give here 1 million. Okay, so now that we are doing this sum, we are going to return the result to do something. Oh, sorry. From do something. Okay, so here I'm going to print this do something, and then since we are working with executors, we need to shut it down. So executor service dot shut down. Now you will see, of course, that we are not getting the value back from the future. The main thread will just do the sum, and then it will shut down without us even getting the response back. So to get the response back, you already know how to do it. So you can add here salt, and then you call the $request dot get, and we have to handle two exceptions. I'm going to add, and we'll show why adding to the method signature is a bad idea later. So I'm going to get, so basically I will do something, and then before I finish my program, I actually need to display this dollar quotation. So I keep doing something, but I need to wait for the response. So Control Shift F10. As you can see, we get the response from the sum, but we are still waiting for 2 seconds as the time that the server is taking to give us the response. But what happens, for example, if it's 15 seconds? Now, your program is kind of getting stuck. One of the threads is getting stuck for 15 whole seconds. The main thread is still available. We could do something else with the main thread, but this now is blocked. So how can we avoid that? How can we tell, hey, just wait for like 3 seconds, and if nothing happens, you just throw an exception, and then you are going to release the thread. So here we could do the following. We can call or pass the arguments. For example, I'm going to wait for 2 seconds. And then I'm going to add this new exception to the method signature. That's the timeout exception. But if we are going to get a problem here, and we're going to see why. So Control Shift F10. As you can see, after 2 seconds, we get this timeout exception. But we do have a problem here. As you can see, the program is not finished. And the reason why it's not finished is because since we got the exception, the line 14 never got executed. That's why the best thing to do is when you are working with asynchronous programming is just to surround with try catch, then you collapse all the blocks, and then of course you are not going to shut down in the catch but in the finally. Now if I execute again, Control Shift F10, after 2 seconds you get the exception, and then you were supposed to shut down. Why are you not shutting down? Let's see. Let's stop the program. The reason is because we are waiting for 15 seconds. So if we reduce this one to 5, Control Shift F10, the shutdown is being executed, but it does gracefully shut down the callable. This happens because sometimes you don't want to interrupt abruptly the task. You could do that, but probably would get an exception. If you would like to have a callable where you have a timeout, instead of submit, you could call invoke all, but then you would have to pass a collection that extends callable, but then you have the option to set the timeout. It's one of the options about having like a time for the task being executed. So as you can see, asynchronous programming is something that's not very easy. It's more advanced, and when you put this into a system with like hundreds of classes, thousands of lines of code, it gets even trickier. So that's it for the future. Now in the next video, we are going to talk about completable future. That's kind of a new version developed by Java to enhance a little bit the future class. So see you in the next video. Bye.